Hi. So I'm going to go through the PAT paper from 2016 looking at question 17. So question 17 gives us a force versus displacement graph and asks us to find in part A the work done in moving an object of mass 20 grams that is placed at rest at x equals 5 centimetres to move to x equals 0 centimetres. So we notice we have a force versus displacement graph, and we know from definition that work done is force times displacement. And so we have force along the bottom and displacement on the bottom and force along the top. So if we multiply them, we get the area. So that corresponds, that tells us the area underneath this graph will tell us the work done in moving an object from one point to another. So we're moving from x equals 5. So if we come across from x equals 5, we get that corresponds to a force of minus 10. So we see we have a triangle here of width 5 and height 10. What we have to be careful about, as we've been working out this work done, we've been given the displacement in centimetres. So the work done is actually equal to 0.1 metres times the force, sorry, 0.05, so it's 5 centimetres, so 0.05 metres times the force, which is 10 newtons. And that comes out as 0.5 joules. Okay. B says, what is its speed at x equals 0? Well, we know it started from rest and it had a work done on it. So we know that this work done is going to be equal to its change in kinetic energy, presuming it's not gaining any other form of energy. So that's equal to 1/2 times m times its velocity squared at x equals 0. Well, therefore, 0.5 is equal to 1/2 times 0.02 v squared. And therefore, 1 divided by 0.02, which is equal to 50, is equal to v squared, and therefore its velocity is equal to the square root of 50 meters per second. Okay, so in part C, we're asked to describe its motion after reaching x equals 0. Well, let's think about this. So it's going to reach, starting from rest here, it's going to accelerate in the negative direction up to a maximum speed of root 50 meters per second. But then it's going to experience a positive force. So this positive force is going to be acting to slow it down, acting in the opposite direction to which it's travelling. So it's going to be slowing down until the work done on it is equal to the work done on it down here. And at that point, which will correspond exactly to a distance of minus 5 centimeters, it will be stationary. And then the force will do work on it to accelerate it up to, well, it's the same work done, so exactly the same speed. And it's going to come down here, and exactly the same thing's going to happen. It's going to be slowed down by this force until the same work is done, and it's going to stop here. So we're going to have it oscillating backwards and forwards between these 2 points. And what is actually an interesting point to note is that this is the exact graph of force versus displacement for what is known as simple harmonic motion. So the mass will undergo simple harmonic motion between the points x equals 5 and x equals minus 5 about x equals 0.